Hi everyone, I'm Michelle from Hing Construction, the project manager of InnoCell at Hong Kong Science Technology Park. Firstly, I want to once again express our gratitude to Autodesk in presenting this BIM award to us. We are very happy to share our experience from InnoCell, a pioneer modular integrated construction project, as well as the first high-rise MiC project in Hong Kong. Looking back, InnoCell commenced construction back in August 2019, and it was completed in October 2020 recently. From site possession to completion, the whole construction process of this 17-story building only took merely around 1 year, which I believe is a remarkable breakthrough in our construction industry. Therefore, we are pleased to be invited by AIAB in sharing our stories from design to construction with the extensive adoption of BIM in this event. And in the meantime, allow us to mutually be involved with other new technology applications from other practitioners. For the first part, I will briefly introduce the overall background of InnoCell. The concept of InnoCell begins with the aim to attract more technology experts from all over the world to work here at Science Park. As per findings, many of them expressed their concern on high rental costs in Hong Kong, which creates a huge obstacle for them to decide to stay here in Hong Kong or not. In response to their concern, Science Park therefore make use of a nearby area to construct a residential tower that specifically offer lower rental prices. That is why you can see here, the location of InnoCell sits right at the entrance of Science Park, which serve as a very convenient and intermediate position for them and facilitate them to work and travel. Back in early 2019, the concept of MiC is still very new to us. The whole construction process of InnoCell has definitely received an extensive attention from everyone, including the government, education institutes, and other practitioners. We are also delighted to have the Hong Kong SAR Chief Executive Ms. Carrie Lam attending our commencement ceremony. We also conducted a roadshow to demonstrate different prototypes of interior and exterior design for tenants' preview. Besides, we also received many statutory bodies, including the Defense Bureau, Buildings Department, Transport and Housing Bureau, Water Supplies Department, and etc., visiting our MiC factory in China during our fabrication, as well as different practitioners to our site. Through this visit and several months of discussion, we have exchanged a lot of useful information on workflows of manufacturing, fabrication, delivery, and all the way to installation on site. BIM modeling, together with a common data environment working across the border, has definitely played an important role throughout the whole process. Our BIM engineer, Tommy, will share more about it afterwards. Speaking of the MiC module design, there are altogether 418 MiC modules in total. In typical floor as shown here on screen, MiC construction covers around 70% of the floor area. It is also worthy mentioned that we obtained the first BD approval of pre-acceptance, GBP, and superstructure in adoption of MiC system, which then opens the road for future MiC adoption. There are in total 4 room types, single room types, namely the standard studio and co-living, twin bedroom, which is called the sleep box, and lastly, the family unit, which comprise 2 modules. And here are some finished product photo records. We emphasized a lot on usage of new technologies in the room design. For instance, home automation and unmanned services on indoor temperature and lighting control. These can be operated through vocal or smartphone application controls. Booking system of common facilities in the building is also managed by a smart central system.
Good morning everyone, I'm Tommy, the Senior BIM Engineer in Hing. Just now, Michelle has summarized the final MiC interior design of InnoCell. Although this construction technology is quite new in Hong Kong, we could still take reference from other projects like in mainland and in Singapore. Moreover, referring to our project team from client to the subcontractors, most of us are accustomed to using BIM already. We can account for the potential challenges and solutions along the whole project lifecycle. So here, I shall define the unique challenges of MiC into 5 main scopes, starting from the module fabrication in mainland factory, and then transportation of the finished modules, followed by the necessity of well-organized site planning program, the installation method of modules, and finally, the specific safety issues. I will also share with you how we utilize the BIM functions to support our project team in getting through these challenges. Module fabrication also stands for the starting point of MiC. Here, allow me to ask you a question first. When you are about to start a massive production, what gateways will you set before you proceed? I believe everyone shall agree that we must first guarantee that the fabrication is valid for future installation works. Otherwise, once the production line begins, the fault will be repeated for every module, and the remedial works will seriously defer the construction program. What if our factory locates in Jiangmen, China, which is 3 hours driving distance away from our site? So you can imagine the communication between these two areas becomes more difficult. Not to mention that we cannot even reach the factory since the COVID-19 outbreak. But luckily, our coordination footpaths are all stored in the cloud platform, and our design consultants were using BIM since the design stage. We can, therefore, develop a construction BIM model based on their handover models. We have also set a workflow together with our subcontractors, so that each of them could contribute their expertise in developing our BIM model. Here, we would like to emphasize 2 critical factors leading to our success in utilizing BIM. They are BIM traceability and BIM diffusion. The first one, traceability, regards on the vertical timeline of BIM modification, which we are very lucky that our client, Hong Kong Science and Technology Park, and our architectural consultant, Lee and Orange, put much effort in offering the design BIM model. We are also delighted that our MiC contractor, E&M contractor, and facade contractor are willing to shoulder that diffused part of modeling responsibility, so that Hing, as the main contractor, we can focus more on BIM model federation and analysis. Having these great project partners make the BIM geometry and information to be trustworthy. And we have also derived extra value of BIM model by combining it with other technologies. For instance, our first analysis is to create an exposed view of MiC module. Our aim is to demonstrate the extent of maturity we can complete before we shift these modules to the site. Our subcontractors also make use of this exposed view to identify their scopes of work and instruct their workers in installation. This is the initial step of fabrication. Our MiC vendor provides us the latest steel frame structure in BIM for our verification and endorsement. After that, they start the manufacturing process to achieve lean construction. In our experience, the MiC factory can assemble up to 50 module frames in one day. That's why we must rely on early collaboration through BIM to prove that all the hindered clashes or buildability problems has already been resolved. Here are the proceeding steps after module frame assembly. In step 1, a mature BIM model also helps to save materials, like the strengthening plates for MEP fixtures. Also, as highlighted in step 2, BIM serves as a medium to maximize the efficiency of DFMA, which is the execution of design for manufacture and assembly. Our ultimate goal is not only to complete the design for manufacture, we also target to enhance the assembly of module in the easiest way. Therefore, in our project, we make use of the BIM model to indicate the demarcation of installation in the factory and later interfacing in Hong Kong. As a result, you can see from the left-hand side, that the work allocation for pipe ducts are neatly defined from factory part in China to final interfacing part in Hong Kong. And at the right hand side, the electrical power in the modules can also be easily connected through the tailor-made electrical box that will be further installed on site. After the first batch of mock-up, we have also generated some renderings to simulate the as-built environment. This kind of renderings only takes us about 1 or 2 hours, but in turn, it consolidates the impression of the built environment that our clients might expect. In order to shorten the time and distance to monitor the manufacturing progress and manufacturing quality in the factory, our project team has also applied an online inspection system. In the system, all the inspection forms are only required to be signed through a mobile app. Different workflows has already been established in the app so as to cater for different inspection objectives like water testing or defect making. The role of BIM is to embed a link into the navigation model. This kind of digital works supervision system is a good way to connect our project team and the inspectors in the factory, which eliminates the problem of distance communication. Now, the first batch of modules has been completed and they are ready to be transported to our site. There are altogether 3 milestones of the whole transportation. The first one, from mainland factory to Hong Kong port through shipping. And then from Hong Kong port to InnoCell entrance through a wide loading truck. In these 2 processes, we adopt real-time GPS tracking system to closely trace the location of these modules as a means to foresee the stock of modules and review the short-term installation sequences. Now, when the vehicle is entering the site, we need to pay extra attention in planning this route. Because the site area is very congested, we need to find the best vehicle swap path in order to protect the modules, relieve the driving pressure for drivers, while at the same time minimize the waiting time for other road users. To achieve this, we took a few steps to make sure our swap path analysis is workable. We first acquired the general surrounding site layout from InfoWorks. The advantage is that it already equips some trivial GIS geometry and data, like the roads, like the sea, like the mountains, and some buildings nearby. After that, we can incorporate the InfoWorks models into our construction BIM model, and then try to run the swap path analysis in CIFO 3D. At about 2 weeks before the first batch of module arrives, we are already familiarized about the vehicle swap path analysis. We then invited our technicians to do the 3D laser scanning, which gives the accuracy up to 2 mm in 150 meter distance. The laser scanned point clouds are also stitched with the point clouds from the drone scanning. By doing so, we can obtain a full picture about the site activities and identify the obstacles that must be removed. Also, we can make use of these accurate scanning results to identify, analyze, and comment on different vehicle swap paths. Through these kinds of optioneering procedures, we finally choose the following swap path. So let's take a look together. So now you can see the combination of point cloud and the truck, and it is driving a bit too slowly. Oh yes, it's faster now, and it goes to the entrance gantry now. So you can see for each critical checkpoint, we give the dimension for clearance, and the storage area is highlighted in gray. And there are something that we need to be removed. Now the module is unloaded and the truck is passing through a group of columns, which is proved to be feasible under this analysis. And the scaffolding here should be removed. And then we spot that this exit gantry needs to be widened in order to allow better turning angle. So we try another scenario to widen the gantry. And then we want to prove that the truck can have a wider clearance for the turning angle right now. This is another analysis when the exit gantry is in use by other site activities. What we want to prove is that using 3D scanning is a full perspective approach. We can identify many ad hoc site activities that might have been overlooked by purely looking at a 2D site layout plan. Also, we can explicitly simulate the safest and the most efficient vehicle path to safeguard the real practice.
So now I'm going to talk about our construction planning. We evenly distribute 30 modules installation at each story by the operation of 2 tower cranes. And as you can see on the layout plan, temporary storage areas on site were extremely limited. That is why just-in-time material delivery is crucial in overall project management. We have adopted a call-ahead construction approach, followed by MiC module installation in lower story concurrently. Both operations are conducted in a super fast-track 3-day floor cycle simultaneously, which are simulated in the construction animation. Given the aid of BIM, complex construction planning was illustrated clearly in 4D sequencing animation. Furthermore, a full BIM collaboration practice also benefits in allowing module comparison among different construction phases. In InnoCell, 5D quantity taking off schedules are generated as a reference of bills of quantity for interim payment certification. The construction model could be compared with the design model and serve as a benchmark for variation assessment. As a result, the site progress was promisingly fast-tracked. In early March 2020, we just installed around 40 modules at Tower. And not long after, in late May, we complete all 418 modules and top out the 17-story tower successfully. Other than only traditional application of drones, which is to take aerial photos and videos, we also adopt 3D drone scanning by combination of thousands of photos into a formation of geogrammetry. The advantage is that full perspective site views are shown clearly, and any site areas that might hinder MiC module lifting operation could be spotted. Besides, the scan model can be merged together with the design model in order to better understand the relationship between actual progress and upcoming works. This table summarizes the benefits and highlights of different site recording methods we adopted in InnoCell and how they are integrated in our daily site operations.
With a comprehensive planning of site arrangement, the next part we need to consider is how we install the modules permanently in place. To explain our proposal detailedly, on one hand, the hoisting and installation method is graphically annotated in the method statement. On the other hand, we also demonstrate the whole procedure through BIM animation. Let's watch the video together. At first, we assign the stock of modules to be 2 layers in maximum. We also need to guarantee that the scaffoldings has been removed for MiC installation, and there will be safety fences at the floor boundary to protect the workers. The safety railings are also installed on the topmost stack of modules for protection as well. Now, we place the spigot to guide the upcoming module into rack position, and then we hoist the upcoming modules. And then we use the bolt and nut method for permanent fixing. When the entire zone of module has been installed, we then concrete the lay cast strip to tie the modules with the core building. You can find that the whole installation sequences become very understandable after this animation. Other than animations, our clients and some frontline workers want us to demonstrate the procedures step by step. Therefore, we make use of coordinated frame model from BIM to generate different 3D prototypes. We specially 3D printed the corners of 4 coherent modules in 1:2 ratio size. And then we can bring these prototypes to provide recurring demonstrations. In the design, there are gaps between every modules to serve the fault tolerance. We then place a shimming plate on top of the corner boxes to tie the 2 modules together. And if any module does not lie on the right level, we can level it by using some plates. Now we place the spigot for guiding the upcoming module. And then install the upper deck module 1 and also upcoming module 2. And then we fix the modules by bolt and nuts method. So, through this practical demonstration, we can imitate the gesture of bolt fastening using conventional methods, where you can see that the conventional fastening using spanners method is tightly constrained by the neighboring steel members, as you can see. This triggers us to consider alternative fastening methods. And the final steps here are to fill in the gap with fireproof rock wool, stick the waterproof tape, and then paint the waterproof coatings. So we have just mentioned about module hoisting and fixing. However, can you guess the weight of one module? These modules are actually so heavy that we must handle them very carefully to avoid any accidents. Besides, we have just mentioned that safety railings must be installed on the upmost deck of module. In response to this, our MiC vendors provides us an innovative and efficient solution. As you can see at the right hand side, there are several small plates with standard thrust size. They are already pre-welded to facilitate easy installation and demolish of safety railings on site. Other than railings, you can also see a red arrow pointing at the middle top of the module. What's that? As shown on the graph, it is actually a pre-installed anchor point to let the workers lock their safety harness there when they are working outside. These fixtures are designed inside the gap between the upper deck of module and the lower deck of modules. So, it does not need to be cut off anymore. The whole design concept emerges because we have incorporated the MiC models with the construction site model together. So, this is a result of our collaboration for DFMA. It effectively speeds up the site installation progress. And it also reduced the pollution created from the cut-off works of ironmongery. Let me answer the loading of a module first. It actually weighs 20 tons as gigantic. So if it's collapsed from lifting up procedure, the whole consequence will be very disastrous. Therefore, it is also crucial to raise the workers' awareness to keep away from the danger. We therefore try to incorporate a VR experience during the safety induction trainings and let the workers get immersed in the scenario of MiC module storage area. They are going to lift a module onto the building, and then we will encourage them to raise out all precautionary measures before getting into the next procedure. The feedbacks are positive in general. The workers think that this experience is actually quite funny, and hopefully we wish them to leave stronger impression when they are trying this new technology in the first-person perspective. Finally, we also cooperated with a technology startup to equip a device into the helmets for our lift shaft workers. It detects their health and physical status in real time. If any abnormal situation happens, the system can also instantly alert our safety officers. The character of BIM here is to provide a simple and clear 3D layout from the model. That the system will have an app to indicate the position of workers and their status in the interface of 3D layout. So that's it. Wow, We have gone through quite a number of applications, especially the application for DFMA and vehicle swept path analysis. But I want to emphasize one point. That is, such extensive applications and such incorporations with other technologies, like the safety helmets, are all originated from a trustworthy BIM model. Our project team has devoted huge effort to shape the model as a digital twin with the actual entity. A mature design BIM model is the fundamental to build an informative construction model, and more engagement of subcontractors shall result in more professional contents in the whole BIM model. Here are some of the achievements that we have met. I think the worthy mentioned ones are that our modules are 100% valid to fulfill the design and installation requirements. And then BIM coordination can be settled 2 stories before the concrete casting. We also achieve 0 accidents through the whole construction period, and then we can catch up with the construction schedule despite that the challenge spawned by the pandemic. And one more achievement to add, that is, we have been awarded by the Autodesk last year. Thank you, Autodesk. Finally, I hope to take this opportunity to express my gratitude to the managers in this project, including CK, Michele and Billy, for their unlimited support to the BIM team. I would like to also thank our client, Hong Kong Science and Technology Park, architects Lee and Orange, and all design consultants and subcontractors who have taken part in collaborating in the BIM environment with us. We believe the good practices and lessons learned in BIM applications here could serve as a benchmark for future MIC projects. That's all. Thank you, AIAB. Thank you all guests for your listening. Have a nice day.